And we're going to be using the calculator in this chapter a lot, because the arithmetic's not hard, but it's tedious. Very tedious. Okay, chapter 2 is about systems of linear equations and matrices. And matrices are the same thing as a system of linear equations.
It's not working in year 5.
I didn't look, I'm going to do this.
Okay.
Is your screen locked?
This is in D2F.
This is in D2F. I could put it in Nearpod, but I figured I would leave it in D2F.
I just want to know why I'm part of this.
Okay. Okay, this is about systems of linear equations and matrices. And we're going to learn how to solve systems of linear equations by something called the echelon method. So I'm going to explain what it is, and then I'm going to show you how to do a problem with it. This is an application of where this would be useful. Farmer's got animals that he needs to feed, and it has to be made from 2 different ingredients, corn and soybeans. And it has to have a certain amount of protein and a certain amount of fiber to feed his animals. So what the problem is telling us, and they've summarized in the table, is that 1 serving of each ingredient provides the number of grams of protein and fiber shown in the table. So therefore, corn provides 3 units of protein and 11 units of fiber, and soybean provides 10 units of protein and 4 units of fiber. But for the farmer, he has to have a certain mix of protein and fiber, and he needs to know how much of those 2 grains to mix to get what he needs. So what we want to know is how many servings of corn and soybeans should be used to make a feed that contains 115 grams of protein and 95 grams of fiber. And we're going to let X be the number of servings of corn, and Y is going to be the number of servings of the soybeans. So that top row gives us the equation 3x plus 10y equals 115. 3 units of soybeans and 3 protein units per unit of corn plus 10 protein units of soybeans gives you the amount of soybeans, and it has to total up to 115. The feed also has to supply 95 grams of fiber, so we'll use the second row, and since each corn unit contributes 11 grams of fiber, we have 11x, and we're going to mix it with soybeans, 4 units of soybeans, and Y is going to represent how many units of soybeans that we need, and that has to total up to 95. Now, before I go any further, I know I started you off on a word problem, because that's what this is good for. Questions about how I came up with any of this? Does this make sense? Okay. I think you probably did this at least a little bit in 1100, or in whatever your algebra classes were. So what we want to do is we want to solve this problem by finding units or values for x and y that satisfy this system of equations. And we're going to verify that x equals 5 and y equals 10 is the solution of the system by my going through the problem with you. And that is the only solution of that system. So this is what we're going to do to actually solve that system of equations. You first have to recognize that it is possible to have a system of equations or 2 equations that don't have any solutions in common. Hopefully, it has at least one solution in common. Some systems of equation have many, many, many solutions, infinitely many solutions. We're gonna look at the graphs to see when that's so. Our setup problem graphs like this, where the two lines actually cross. That's called a consistent system of equations. This is also a consistent system of equations, but the thing is, both of the graph lines are laying on top of each other, and it looks like there's just one line, even though there's two equations. That's also a consistent system, it's just that every point on one line is the same as all the points on the other line. The one in the middle is called an inconsistent system because they don't cross, ever.
Can I finish off?
So let's stop and verify that the solution to this system is what I said it was. This is how we're going to do it. We use something called transformations to change the equations around, and we can add, what we can do legally with these equations is we can swap them from top to bottom, bottom to top, because that doesn't change their value. We can multiply all the way through either one of the equations by any non-zero number, because that doesn't really change what the equation is. Or we can add two equations together, and we can combine those operations if we want to. So this is how we're going to do this one. We're going to solve the system by first looking and saying, well, you know, I'd really like to get those x's to drop out, because then I only have one y left in the equation that I would have to deal with. So what I'm going to do is I'm going to multiply the top equation by the coefficient of the first term in the bottom equation. So that's going to be 11. And then I'm going to multiply the bottom equation by the coefficient of the top equation, but I'm going to make it negative. So when that happens, 11 times 3x plus 10y is 33x plus 110y. And 11 times 115 is 1265. And then negative 3 times 11 plus 4y is negative 33x minus 12y. And negative 3 times 95 is negative 285. So what happens now is that this adds up to 0 if I add the two equations together. And I get 98y equals 980. And that means that since, that's an equivalent equation, I'm just going to drop that second equation out and replace it with that. Now what that tells me then too is that 98y equals 980. It says that y equals 10. Because if you divide both sides by 98, you get 10. And if I know that y equals 10, then I can go back to the original equations and plug in and solve and find out what x is, and it turns out that x is 5. Now I don't really like the total way that they did it, so I'm going to show you an easier way to do this.
Thank God.
Okay. Their way works, but I think it's kind of roundabout because they introduced fractions in it, and you're sitting there saying, where's the fraction come from? Okay, let's switch over here. Our goal here is to turn the coefficients of the x terms into opposites, so they'll cancel each other out. Okay? So I'm gonna take the 11, and I'm gonna multiply it times 3x plus 10y equals 11 times 115. Because you know from all the algebra you've ever had that you can multiply both sides of an equation by the same thing and you don't change the equality. Then because I want this 33x to cancel out, I'm going to take the 3 and make it negative, so the signs will be the opposite, and multiply it times 11x plus 4y equals negative 3 times 95. So that's my first step, is to multiply those all together. And when I do that, I wind up with 33x plus 10y equals, and I'm going to get my calculator because I don't remember what it was. Okay.
No, that's H-A-Y, or would you?
Yeah, you gotta multiply.
Oh, no, that's, I left out one of my ones. It's 110y, thank you. Okay, then for the other one, I've got negative 33x minus 12y equals negative 3 times 95 is negative 285. And when I add these together, I get 0 x's, which you don't even have to write down. And 110 minus 12 is 98. And 265 minus 285, or 1265 minus 285 is 980. Divide both sides by 10. And I'll find that y is equal to 98. Now, instead of using up to that point, that's exactly what I showed you a minute ago. Okay, is everybody good with that so far?
Why would you divide it by 10? Why
You wouldn't, I'm sorry.
Jump to the answer, that's all.
So that answer's 10.
Just the answer.
Because the answer's 10, my brain was on the answer being 10. Okay, so that's what I've showed you so far on the PowerPoint. Now, this is where I take off from them, because I don't like the way they did what they did. I take that y equals 10, and I go back to the first equation. And I substitute it in. That means 3x plus 100 equals 115. And if I subtract 100 from both sides, I have 3x equals 15, and then x equals 5. And I didn't have to deal with fractions and stuff they were using. Now, if I want to be sure my answer is right, then I take x equals 5 and y equals 10. And I also go back to this second equation up here and say 11 times 5 plus 4 times 10 equals 55 plus 40 equals 95, and that's what it's supposed to equal. So the solution has to work in both equations. Okay? The way you would write your solution is as an ordered pair. And because it's an application problem, we're gonna translate that and say the required feed would mix 5 units of corn and 10 units of soybeans. Okay? You always answer a word problem with a sentence, because it asks you a question, you want to answer the question. Not just find out what X and Y are. Is everybody okay on that one now? Any questions? Okay, we'll move on. So this is the same problem. It's just solved graphically, and you could solve it graphically on your calculator as well. All you'd have to do is graph both those lines and find out when they would intersect. But our goal is to solve them algebraically, enough for you to get used to the idea of what we're doing, so we're going to do one more. And then I'm going to show you how to switch it over into matrices and do it on the calculator. So we're going to solve this system. And I'm going to let y'all tell me what I need to do.
Top one by 3, the bottom one by -2.
Okay, sounds good.
Vice versa.
Either one.
It does it.
So I can multiply this by -3 and this by +2, or I can multiply this by -2 and that by +3. It isn't magic that I have to eliminate the x's. I could, if I had a nice situation already set up, I can eliminate the y's first. You can eliminate one of the two variables.
That's what I was gonna ask you a while ago, because they made it sound like you had to do something on the homework or something like.
No.
When they did that PowerPoint thing or something, I took it like they had to do the Ys.
You don't have to do either one. In fact, I'll show you this one eliminating the x's, and then I'll go back and show you the same thing and get the same answer eliminating the y's.
That's what I thought on the last class, there were different ways you could do
There's-
this, and not that echelon thing.
There's at least 4 different ways
Okay.
to do this.
Will you require us to do one or the other?
When you see how you can do it with matrices, you're not going to want to do this at all.
Okay.
So one way we're going to do this is we can take -3 times 2x plus 3y equals -3 times 12. And +2 times 3x minus 4y equals 2 times 1. And this plays out to these two equations. -3 times 2 is -6x. Oh, I guess that would help. I'm glad y'all are patient. -6x plus 3y equals -36. 2 times 3x is 6x. 2 times -4 is -8y. And 2 times 1 is 2. So I'm just going to add them together now. These are gone.
Would that be 9y, -9y?
-9y at the top.
Ah, yes. I think I might need to go back and get some
Negative.
coffee. Yeah, it is a negative. Thank you. When I add these together, I get -17y and -34. So I'll divide both of them by -17 and get y equals +2. And now that I know y is equal to positive 2, then I will go back and say 2x plus 3 times 2 equals 12. 2x plus 6 equals 12. 2x equals 12 minus 6 is 6. So x equals 3. And then I'll check by going to 3x minus 4y equals 1. And I can actually check both of them at this point. So it does work. The solution is for both of them. Now what we were talking about, do you have to do it that way? No. Let's take this same system, and I'm going to solve it by getting rid of the y's. So I'm going to multiply the top equation by negative 4.
Just do regular thing. There's no good long thing. They're already opposite.
Yeah, they're already off.
Now here, I changed the sign on the first one, but I really didn't need to, because if you notice what's going to happen here, this is going to be negative 12, and that's also going to be negative 12. That's because they had opposite signs to start with. So I really didn't need the negative. I just needed the 4. Okay? So 4 times, whoops, where's the pen? 4 times 2x is 8x plus 12y equals 48. 3 times 3 is 9x minus 12y equals 3 times 1 is 3. The y's dropped out. 48 plus 3 is 51. And 8 plus 9 is 17. So I'll divide both sides by 17. Yep. And it's still x equals 3. And then I can go back and do the same thing as far as checking for the y value. Now I'll just plug in my x value. 2 times 3 plus 3y equals, see, the original value was 12. 6 plus 3y equals 12, 3y equals 6, y equals 2, just like we got the last time. So there is no hard and fast way to do it. In fact, I could give everybody in here a problem, and it's entirely possible that everybody would do it completely differently. Okay? As long as you follow the general method, you can't go wrong. Now, it is also possible to have a system of equations that has no solution. And what would happen if this happened to us is that we would have a system like this one, where we have 2x minus 3y equals 6 and negative 4x plus 6y equals 8. And if we took 2 times row 2 and added it to, or 2 times row 1 and added it to row 2 and used it to replace row 2, give you a little more detail. I need to write down the problem first though. So I'm going to multiply the top one by 2, I'm gonna put it down underneath this row because I'm not gonna change that row. So that's gonna be 4x minus 6y equals 2 times 6 is 12. Then I'm gonna add those two. That's gone. That's gone. And 0 plus 0 is 0. But 0 sure doesn't equal 20. That one has no solution. And it's also referred to again as inconsistent. And in fact, what would happen with this is if you graphed, you would only see one line, because actually this equation and this equation are multiples of each other. So they have the same slope. They have the same slope, they have the same y-intercept. I'm sorry, they have the same slope, they don't have the same y-intercept. So if you graphed this system, that's what you get. You get parallel lines because they had the same slope. Now there's also, and that's an illustration of the parallel lines. There's also a situation where they'll have infinitely many solutions, and we will work through. And if I do it up here rather than just talk through the PowerPoint, it'll slow me down, so that's good. Give y'all a chance to take notes. 3x minus y equals 4. Negative 6x plus 2y equals negative 8.
We can't see
I know, I'm copying it down, then I'm gonna switch over. Okay, now I see that, okay, if I multiply the first row by 2 and add it to the second row, I know the x's are gonna drop out. So I'm gonna take 2 times the first equation, so 2 times 3 is 6x minus 2y equals 2 times 4 is 8. I'm going to add those together. When I add them together, that drops out, but so does that. So what I've got here is 0 equals 0. And that's true. So you have infinite solutions. So it's because this is a true statement and the other one is not true. Then if it's not a true statement, there is no solution. If it is a true statement but you have no variables left, that's an infinite number of solutions. Now you can actually go through, and they did a fraction to get the first equation with the fractions, but I really honestly don't know why you would want to do that. And this, of course, shows what I told you a minute ago, that they're overlapping. Now you can use either one of the equations to come up with what's called a general solution, okay? And if I can show you how to do that, go back to this problem for a second. You can do it this way, although there's more ways to do it than that. If you want to solve one of the equations for one of the variables, it doesn't really matter which one. They chose to solve theirs, I think for x, but what I'm going to do is I'm going to go back and get 3x minus 4 or excuse me, minus y, not 4, equals 4. And what I'm going to do is I'm going to solve this for y. So if I want to solve it for y, remember I've got the negative of y, I'm going to subtract this 3x from both sides. And then, because this is a negative y, then I will multiply it by -1, so that I'll have a positive y. And then I'll also multiply this side by -1. And get -4 plus 3x, or y equals 3x minus 4. And then the way that it would work would be you would go back and get the other equation. Now that you've got a value, and they did theirs differently. I'll show you how they did that one too. Since I use the top one to actually create the equation, I'm going to plug it into the bottom one. So I'm going to take this value of y, and I'm going to plug it in for y in that second equation. Oh wait, no, I'm sorry. I think I messed up. No, it'll work. My trying didn't work. Let me go back to theirs. Must have skipped a sign. Let me try that again from the top and try the other variable, because if I miss the sign, I'm going to miss it again. Did y'all ever do that? You make a mistake, you go back and think the same thing looks right when you do it?
It looks like 1 equals 1, is that what you were about to come out with?
No. Now, I was trying to come out with an equation that shows you how you can have one of the variables and have a formula for the way that the solutions will always look. Okay, here we go. Let's try solving for x. That means that I will add y to both sides. And then divide both sides by 3. And the 3's in front of the x cancels, so x equals 4 plus y divided by 3. And then since that's only one variable, then the other variable is going to be the y. So that's what your solution would look like. Whatever value you choose for y, then you would plug it into this to find out an x value that worked for it. And I should have been able to do it with the x's, but or with the y, but somehow my brain didn't work.
So you're supposed to be able to do it either way, you don't have to.
You're supposed to be able to do it either way. me cover that up and see if I can do it without doing that. 3x minus y equals 4. Add y to this side, which takes that away, and subtract 4 from this side. 3x minus 4 equals y. So then the solution would be x, comma, 3x minus 4.
It's just that it's not a fraction, so.
Yeah. I'm trying to eliminate the fractions. Now, even though it doesn't look like those are the same, they will both give you the answers that you need. And we can verify that by saying, well, let's see, this one has infinite solutions. Somebody pick a value for x. Please don't tax my brain too much. Little numbers. 1, okay. So if I use this one and x is equal to 1, here's what I get. So, using the wrong one. Come down here and do it. We take x equals 1. We get 1, comma, 3 times 1 minus 4 is 3 minus 4, so that's negative 1. We get 1, negative 1. I can verify that by saying, okay, let me put negative 1 in for y and see what x comes out to be, using the y substitution. So if y equals negative 1, then x is going to be 4 plus negative 1 over 3, and then negative 1, obviously, because y is equal to negative 1. 4 plus negative 1 is 3. 3 over 3 is 1. So we still have the same solution. So you can do it with either variable, okay? Just watch your signs. That's the biggest trip up in this, is the signs, which is the reason I think when I show you how to do this with matrices on the calculator, you'll like it a lot better, because it's really tough to mess up the signs if we use matrices. And those are called particular solutions, by the way. Okay, the echelon method is a little bit longer and a little more drawn out than what we just did. But it will lead you to understand what the matrix is doing. Sorry. And I told my other class, this is what I would normally classify as a stupid problem. Because if Olinda is so stupid she can't remember which way she invested her stock, she doesn't deserve the money. So she has $8,601 in Kohl's stock and in Best Buy stock. And she knows what they currently sell for, so she wants to know, she's got 188 shares of stock, but she doesn't know how many shares of each one she's got for some reason. So you come up with a system of equations, and in the system of equations, X is going to be the shares of Kohl's stock and Y is going to be the number of Best Buy. And since the Kohl's stock is $52 a share, that's 52X. And since the Best Buy is $27 a share, that's 27, and she knows the value of that all is $8,601. And she knows she has a total of 188 stock shares, so that's X plus Y equals 188. Okay? If we do the echelon method that we just did, we come up with this, and we can back substitute. And if you're curious as to how that worked, we divided through everything on the first equation by 52. I'm sorry, not by 52, by 100. So since you know y is equal to 47, you can find the 141 shares. This is called an echelon method because basically there's a 0 for the first term. If you had a system of equations with 3 variables in it, you would have 3 equations. The top one would have all 3 variables, the second one would have 2 variables, and the third one would have the value of the third variable when you got finished. So let's try this one on our own. Company produces 2 models of bicycles, Model 201 and Model 301. Model 201 takes 2 hours of assembly time. And Model 301 takes 3 hours. And the parts for 201 is 18 a bike. And 301 is 27 a bike. And they have a total of 30 hours of assembly time. And they have a total of $335 available for the 2 models. So we have to figure out how to turn that into a system. And they want to use up all the available time and money. So the first equation we have is going to be about the time. Okay, that's your assembly hours. So 2 times, we're going to call this one X. 2 times X is the assembly time for Model 201, plus 3 times X is the assembly time for Model 302. 3 times Y, I'm sorry. Because those assembly times are going to be different. So this is Y. And that's going to equal 30, we hope.
34.
Did I write it down wrong?
Yeah.
I'm sorry. Yeah, you're right. I shouldn't talk and write at the same time. Okay, now the next equation is going to be about money. So $18 per X and $27 per Y. And they can't total out to more than $335. Which variable do you want to eliminate? Okay. Hmm?
It's gonna eliminate both.
Exactly, it doesn't matter,
Yeah.
it's whatever.
Let's just do this one. We'll verify that what you said is pretty much true. I need to multiply this by -9, which means that this is going to be -18 plus no Y's equals, I'm sorry, plus 27 Y's. I know eventually it's going to be no Y's.
-27.
And 9 times 34, 306. So, yes, the X's are gone, and so are the Y's. So we have 0 equals 335 minus 306 is 29. So they got a problem. They can't produce the bikes and use up all the available materials. Okay? They're gonna have some of one or the other left over, basically. So how many of each should be made in a day to use up all the available time and money? And if it's not possible, explain why not. Well, there's no solution. There is not a solution that lets them use up all the available time and money. Okay. Let's go into 2.2, and as it's needed, I will go back to using the overhead if we get stuck. But I think I can explain the variables disappearing well enough that you won't need that. So put in that Nearpod lesson. And I'm going to sign in too. And we're going to talk about section 2.2. This is the definition of what a matrix is. You need to solve a system of equations. Really, the important thing isn't the variables themselves, it's the numbers in front of the variables that cause you to have to do all the arithmetic. So we've got this system of 3 equations and 3 unknowns. And those 3 equations and 3 unknowns, if we just drop the variables out completely, we'll have a matrix. It's a 3x4 matrix because we have 3 equations and there's 4 entries across each one of those rows. So the rows correspond to the equations, the columns correspond to the constants. Since the array enclosed by brackets is also called a matrix, or more than one is a matrices, every number in the array is called an entry or an element, and we separate the constants by putting a line where the equal sign would have been. Okay? And then they can be transformed, these rows can be transformed exactly the same way that we transformed, we saw systems of equations. And once again, by doing row operations, we can interchange any 2 rows, we can multiply the elements of a row by any non-zero number we want to, or we can add a non-zero row to any other row that we want to. Or a non-zero multiple, I'm sorry, not just a row, but a non-zero multiple. This method is called Gauss-Jordan, and it's an extension of the echelon method for solving systems. What we want to do is we want to take that matrix we just saw and we want to turn it into a matrix where we have just ones along the diagonal. So this is a very step-by-step way of how to do it. We're wanting to solve this system. So the first thing we look at is making it into the matrix, which is 3 minus 4, 1, just the coefficients of the first equation, 5, 2, and 19, which is the coefficients, the numerical part of the second equation. And we're going to rewrite the coefficient matrix, and we're going to multiply the top row by 5, because there's the 5 on the bottom row. And then we're going to multiply the bottom row by -3. And when we do that, we get 15 minus 20 and 5, and -15 minus 6 negative 57. And then you add those two rows together and your 15s will drop out. And negative 20 plus 6 will give you negative 26, and 5 minus 57 will give you negative 52. Are we okay so far? No problem?
We don't have the example one, the same,
Oh,
like
she's
step
on-
by step.
She's on the Nearpod.
I'm on your pod now.
Oh, yeah, this is that PowerPoint that we printed off later. Can you give us a pin then so we can access your file from those?
No, no, you're on Nearpod.
You're all
I
right.
mean, whenever we went over, you had to refer back to this.
I can, or I can actually, I think I can print the near part, but I can always give you a code for just for you and let it stick and paste. Okay? I put a little bit more detail into the Nearpod one because I felt like it would be easier to understand if I did. Okay, are we good so far on this? Okay. Still solving the same system. What we had from the last one was we have 3, negative 4, 1, 0, negative 26, negative 52. And what we want to have happen is we want that negative 4 to turn into a 0. And the way that we do that is to multiply row 1 by 13 and row 2 by negative 2. So 13 times 3 is 39. 13 times negative 4 is negative 52. And 13 times 1 is 13. And then 2 times 0 is still 0. 2 times 26 is 52. And 2 times 52 is 104. And I multiplied this row by negative 2 to make sure the sign's changed. And when my negative 52 and positive 52 cancel out, that leaves me with a 0 for that space. So I'm using the sum of those two rows to replace row 1. Now, we're only a little ways from having what we call the reduced row echelon form. And that is when we have 1s in both of those two positions. And you can change the 39 to a 1 by multiplying row 1 by 1 over 39, or I like to think of it as dividing the whole row by 39 because that's the easier way to do it. And then you can change the negative 26 to a 1 by multiplying it by negative 1 over 26, or basically just dividing it by negative 26. So what we have looks like this. Now, think about what it looks like if we put the variables back in that. Because this is the raw fractions, and I simplified them out, and this is what I've got. So there's your reduced row echelon form. What this actually says right here and right here is that 1x plus no y's equals 3. That means x is 3. And this one says no x's plus 1y equals 2. So y is equal to 2. And the solution is the ordered pair 3, 2.
Now, is there problems where they can only be solved by this method, or will the other methods work just as well?
There will be
Because that seems like a whole lot more work.
Yeah,
the calculator's going to do this work for you. I want you to understand what it's doing.
Okay.
Okay? The calculator's going to do the work for you. Okay? Other than the fact that the arithmetic is nasty and tedious and drawn out, do you understand this though?
Yeah.
Okay, as long as you understand this, then we're ready to go and let technology be our friend. We're going to use Gauss-Jordan to solve this system, but I'm not going to make you solve it by hand this time. I'm gonna skip ahead and then we're gonna come back to solve this problem. We're gonna use the calculator to learn how to do this, then we'll go back and solve that other problem I have in there. We're gonna solve a system of 3 equations with 3 unknowns. And that's a whole page of paper problem if you have to solve it using algebra. What we do is we write the coefficient matrix, 1, -1, 5, and -6 for the first equation, 3, 3, -1 and 10 for the second, and 1, 3, 2, 5 for the third one. Everybody got their matrix? Now, our goal is to use row operations to make it look like that. Where number sign 1 and number sign 2 and number sign 3 are numbers, we just don't know what they are. They're the solution, okay? And there's a mistake right there. That should be a 1 also. I'll have to fix that before I use it again. The last row should be 0, 0, 1, number sign 3. That's our goal, is for it to look like that. If I go too fast, you let me know and I'll come back. Everybody get your calculator. And then we just step by step. And as far as I know, this is the same on the 84 as it is on the 83. So you're going to hit the matrix button. It's circle right here.
Wait, then again,
Yeah, it's harder to see up here.
second matrix.
Yeah, yours may be a second button, but other than that, it looks the same. Okay? Now, what I want you to do, once you get the matrix button pushed, and yours may be a second button or it may be just a button, and you're going to right arrow all the way over to edit. Like this. And you're going to hit enter so that you can choose to edit matrix A. And when you get to matrix A, it just says 0 because there's nothing in matrix A in mine. Now yours may have numbers. That's okay. Don't worry about it. We're going to change the numbers and you can type right over the top of them. You need to enter the dimensions of the matrix at the top. Rows times columns. Rows by columns. Okay?
So like the 1, -1, 5, -6?
Well, no, the number of rows and then the number of columns. So we have 3 rows for the 3 equations and then 4 columns for the 4 columns of numbers.
So just 3,
Yeah, 3 and 4.
how do you just put X4?
Just arrow over here. Yours doesn't necessarily have the X. The X is in on the 83, but you just hit a 3 enter. I think you can look up arrow. That needs to be 3. And then the other number, just arrow over it, needs to be 4. And then when you do that, it opens up the whole matrix for you, okay? So once you get your matrix set up with the right dimensions, that's called its dimensions, then it's got exactly the right number of cells for your rows and your columns.
So then we're supposed to enter the numbers in there?
You enter all the numbers in, starting off with the 1, the -1, the 5, and the -6. This is 2 screens because as you type on some of them, sometimes they'll move over.
Okay, hold on a second.
So I'm gonna wait for everybody to get the matrices entered. Okay, yep. Okay, good.
Oh, is it?
Yeah, the little dots, the edge mean keep on going.
Yes, let's do it.
Yeah, you can just enter through all
Okay.
of them. Okay?
And this will solve any X1 problem?
Yes.
Oh my God, that's awesome. Even fracted?
Yeah. Yeah, it'll even give you the answers in fractions. Okay? So I want you to double check that your matrix is entered right, so what I want you to do is to press the matrix button again, or the whatever second it is,
Okay.
and just hit enter on matrix A. And then hit enter again to get it to print out, and it should look like this.
Here we go.
Unless you've got one of the really fancy new ones, then it might look like a spreadsheet.
I got an error.
I got it here
Okay, let's see.
too. When I get back to my matrix, if I hit enter.
Go
Yeah,
to-
I did that, okay, because I didn't make it, will it take
Yes.
yes. From there, what, from there. There it is. Then just camera?
Mhm. Okay, go ahead.
That's it too much?
You gotta turn your diagnostics on.
Oh, no, you've got 2 of them there. See?
Yeah, well, I didn't. Okay.
That's hit enter. Oh, there you go.
It gave me that.
Yeah, I know. Absolutely.
Okay.
You showed me as well.
Okay, hit enter. Okay, now you've got 2 of them there, so that's not what I'm going to do, that 2. Now just press enter.
And that's it right there.
You can't see it all, because I think you can see yours. If you ever can't see it all, you can always right arrow to scoot it back and forth on the
So
screen.
this is just the numbers that I just entered, just showing you.
Yeah, it's just showing you, all this is showing you is that you entered the matrix correctly. That's the only thing that's gonna be on you. If you don't enter the numbers correctly, you're not gonna get the right answer. Okay? Okay, next step. I want you to go to the matrix again. I want you to go to math. The matrix should say names, math, and edit. You want to do math. And on math, scroll down to option B, RREF. RREF stands for Reduced Row Echelon Form.
Just hit it.
And just hit enter. And then in the parentheses, matrix, and enter to choose matrix A. Enter to get matrix A on your screen. Close your parentheses all over it. Do it anyway, kind of get in the habit of doing that. And there you're in your reduced up row echelon form, did all the math for you.
Did you see?
Yeah.
Did everybody get the matrix that I got on this last screen? Okay, from this you can read the solution straight out. X equals 1, Y equals 2, Z equals -1. It's the last column in order. Okay? Now how hard was that? Did you get it right? Okay. Now, you have to practice it to remember how to do it. But, I mean, giving you one where we hadn't even done one by hand with a 3x3, you see how, you can imagine how tedious it would have been to try to combine all those rows and get that to happen. So now, we will go back. And you try one. And if you can't read that, this is actually the problem on the previous screen. So if you, I'm going to let it go on the previous screen, and then I'll move it over when you have a chance to work it. But the other thing that you can do is you can, if there's a little graph or anything on a question that I ask you, you just click on it, it'll blow it up. This shouldn't take long. And then change the dimensions, and then your stuff on top of it. And then, right, yeah, there you go. I think I yeah, I usually math to the back, you edit it and look at it more. And we had scrolled it back here on the screen. And all the one clear back one. Now start with back to neighborhoods. And forward your math. Scroll back. And then neighborhoods. Okay, we need your row, get your matrix. Commands. Over to math. Now put in matrix A. Close your parentheses. There you go.
When I put it close to figure out C, it gives me there, when I left the first zero,
It shouldn't have made any difference though.
Well, the first time, I did that same thing.
so
and
the
it-
parent,
it-
and give it there.
It's doing that every time, the first time.
Yeah. I got one that has it's aluminum and has an awful keyboard that goes with it. No, it's working now for some reason. Some of them can be very expensive. I don't like the real thick ones. No, it has to be one that goes with these. Well, no, I take that back. It doesn't really have to be iPad style.
Really?
It does not have to be. Try this one. You're not gonna be able to write on that. It's
See,
wrong.
well, see, this, right here is supposed to be, and it doesn't, that's that.
Yeah, you have to be in something that that actually is a writing app. I haven't used it in a while. No, don't worry. You'll know that it is in the right place because there's a little pencil. Let me look at it and see if I can see it. I'll look online up here and see if I can find it. I've got 2 or 3 others. Okay, everybody get your answer? What's X and what's Y? Okay. So on the presentation that I moved you over to now, you can type your answers in.
Do you want it in matrix form or just like the,
Ordered pair,
okay.
since it's not an application problem.
I thought negative two, is mine wrong?
I don't know, I just typed in.
It is negative.
Yeah, that's -2 is what I got.
So I'm not worried about my grade, I just type something in so I can make it go on. Okay? Oop, I'm sorry. And see, I can see your answers up here on my screen. Eddie, are you stuck? I don't have your answer.
You want to use the final calculator on here? Put the calculator?
I think I did it something again because it came up. It says send it again from.
Yeah, if I go backwards a screen or something,
Sorry.
it'll boot you out.
Sorry.
I'm gonna run to the bathroom soon, or are we taking?
Okay, we can take a break after this one, and then we'll pick up from there.
All the things.
Now, the good thing is if I mess up and go backwards, you can change your answer if you figured out that you made a mistake too. Let's see, it's 7:35. Take about a 10, 15-minute break.
Do you know how to clear these without deleting them, like?
You don't have to, you can always just change the dimensions on them, type in whatever
Right
you
over.
want.
So if I start using like V, there's no way to get rid of that without like deleting the whole memory or something?
Yeah, pretty much, you reset the memory, that's it.
Okay. I thought I could get rid of these here, I thought that maybe,
You can make it 1 by 1 and put a 0 in it, but that's what the factory default is anyway.
okay. I don't want to delete it because I thought it was gonna be like the, lists where you delete one and you have to
No.
insert one back in
No.
there after.
No, it doesn't work that way, thank goodness.
I had to look up a video just to get my list back in there.
Yes, I've done that.
X plus an 8. Think you do,
Change some more times.
I don't even know for sure. Oh, yeah, I will. Certainly before in the morning, as soon as I can get them loaded up when I get home, I will try.
well, if it's just a grade, I don't, but I, like I said.
Yeah, well, I can get that done quicker. I thought I had it figured out. Okay. Tap that, pick out the new one line. Tap that, you wanna do a column. And when you pick this one, you can also pick different colors, so I don't have to go in with them, go to the narrow one. Even though it's, yeah. Okay. And one thing you can do, if you open up a PDF document, which is probably something I'll do later on here with Shelby, do a lesson there, and I'll put like a PDF for y'all to work on in there, and I'll show you how you can blow it up and actually write on it, and it looks really neat, and then you shrink it back down, it looks like somebody wrote on it. Okay, back to your part. We've already done this part. Now, what's it gonna look like if we have a system of linear equations that don't have a solution? And I can tell you that one doesn't have a solution, because if you multiply through the top one by -3, you will wind up with 0 equals some number. Okay? So we're gonna do the matrix for that one. So make your matrix A 2 by 3. You can use the other matrices if you want to. You can't lose them like you do the list when you're doing problem stats and trying to fit models. So what happens when you get your matrix in and you do your your RF matrix A, you get 2 zeros on the bottom row instead of getting a 1, 0, 1. Let me see, it's kicking me down back there. Okay, let me, okay, the reason it's happening is because when you finish putting your matrix in, you don't go back out the whole screen. You guys see where this is? It's trying to do something there, but it doesn't know what to do with it. So what you want to do is that last entry is supposed to be what? Make sure it still is. You can always just hit clear again and okay. And let's go on ahead and make sure it's in there. Yep, it is. Okay, so from here, you just hit clear, well, not from there, because it'll be right. So when you get down to the last entry, after you hit the last entry, second mode to get out of there. Okay?
So before I did it, after I check it.
Yeah.
I said the second one.
And then go back
You go over
to the matrix, and over to math, and down, and it'll work. But you have to actually get out of the matrix before we can do the row rec. You have to go back to it.
Well, I get it. Okay, that makes sense.
Yeah, but you're doing the same thing she is. I think the calculator is just confused as to what the problem is. So just hit second quit from there, after you get your entry in there. Got it? Okay? So does everybody see why this is a system that has no solution? Because your bottom equation translates to 0x plus 0y equals -1, and 0 is definitely not equal to -1. Okay? So it gives you the same information as the other ones. I think I'll let mine lay back there. All right.
What's the name of
Okay, this one actually is going to have an infinite number of solutions. You can practice putting this one in if you want to, but just verification is what's gonna happen on the bottom row. You're gonna get your last column, your last row is gonna be all zeros.
Oh, yeah, I got decimals.
Which the bottom row is,
Oh, okay.
okay? Where the last row is. Okay, now, here's what you can do if you need your answers as fractions. This is one little extra thing if you don't want those big long decimals, and you want actually the fractions. When you do your RF matrix A, then hit your math button and choose frac. And it will actually make your matrix as a fraction.
Okay, say that again so I can write it down.
It's just one more thing you do at the end of your RF matrix A,
Okay.
is then you hit the math button. And you choose fraction, and then hit enter. So you should be able to transform the matrix you've got right now into a fraction just by hitting the math button and having it repeat the last thing by that it has, and put it out there as a fraction for you.
Oh, yeah.
Okay? So if it were something where fractions would be more convenient than having decimals, then you can get the actual fractions. And this is just the conclusion of the instructions on that last one. So the third row is all zeros, and that gives us no information. If there were a unique solution, the third row would tell us the value of z, but it doesn't, so we know the system is inconsistent, but dependent. And we'll let the independent value be x, and then find the equations to define x and y in the first two rows. So z, which is the one that it gave us no information about, we're gonna keep z. What we do is we take, and I'm using the fractional one because it's easier to write the equations. Since I'm gonna write it in terms of z, I'm gonna solve 1x plus no y's plus 1/7 z equals 12/7 to get this. And then I'm gonna, no x's plus one y minus 4/7 z equals negative 6/7. I've got a typo there. Yeah, that should have been negative. And then because I don't like those fractions like that, I can also write it this way. And just, add this over to the other side and divide both terms by 7. And then add this, actually subtract that over to the other side. And then add this over to the other side. And it should be added, not subtracted. And then divide by 7. And either way you want to write it, it's fine. But I do have a sign typo in there. That 6/7 should be negative. And you have no idea how fun it is to try to edit these things in real time. So I'm not even gonna bother. Okay. Example 6, soda sales. Convenience store sells 23 sodas one afternoon in 12, 16, and 20 ounce cups, and the total volume of soda they sold was 376 ounces. Suppose the prices for a small, medium, and large are $1, $1.25, and $1.40, and the total sales were $28.45. So the number of sodas is going to be the x's plus the y's plus the z's equals 23. The volume of the sodas is going to be 12x, 16y, and 20z, and it has to total up to 376. And then the price of the sodas would be $1 times x plus $1.25 times y plus $1.40 times z, and that equals $28.45. So that's the matrix that we're going to put in. And your textbook tells you in one place that you can clear the decimals of all of this, but there's no need to because your calculator doesn't mind decimals. It works just fine. So I put those exact numbers into the matrix, and I did row ref matrix A. So how many of each kind of soda did they sell? Do I need to wait?
6, 9, 8.
Okay. Good deal. And then it says, suppose the prices for small, medium, large are changed to $1, $2, and $3, and all the others kept the same. How many of each size did the store sell? All you have to do is go back in and change your cost of your sodas, your bottom row. What happens when you get that is that you wind up with an inconsistent system. Now, if I did row operations, and I left the row operations out of this because I thought, who wants to do that? Then I do it this way. When you do row operations, you won't always get the same answer at the end, but it'll still come out that it's inconsistent. The one I did, you got 0 equals 1955, negative 1955, which you know is not true. So the thing about it is, the best thing about matrices is they make this all very quick. You know you're going to get your answers right. All you have to do is be sure you set the equations up right. if you're not given the equations. And on this page, let's see. This was, it changes, but the total revenue is $48. And you do get a row of zeros across the bottom. Well, 0 equals 0 is true. So there's more than one solution possible with that price. So what happens is that since this tells us Z can be anything, that bottom row, then you define your other two rows in terms of Z. 1x minus Z equals -2. So move your Z over, it becomes plus Z minus 2. And then 1y plus 2Z equals 25. And since that's 1y minus 2Z plus 2Z on the other side, I'm sorry, that's plus 2Z, so when you take the other side, it's minus. So y equals 25 minus 2Z. So if you're asked for explicit solutions, you'll actually just be letting this be called what's called a parameter. It's the one value that you'll have to pick, and then it'll tell you the values of the other two. And if you do row ref, it's always going to be the last one. It's always going to be the Z. And then the problem, you need to realize that X, Y, and Z will always be non-negative integers. So for Z minus 2 is equal to or greater than 0, that means Z's got to be larger than 2 or larger. It also means that 25 minus 2Z has to be equal to or greater than 0. And that means that Z then would have to be equal to or less than 1250. So all of the answers have to be between 2 and 1250. Because that's the independent variable. That's the number that you can plug in to get the rest. So you actually have 11 solutions, and they correspond to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, because you can't have 12.5. It has to be the answer. Okay? So that's how many, whatever the largest sum is. And then the others will fall around that. So it says give the solution from part C that have the smallest number of large sodas. The smallest number of large sodas, Z is equal to 2. That means X is 2 minus 2 or 0. Y is 25 minus 2 times 2, which is 21. So there's no small, 2 mediums, and 21 mediums and 2 large. For the largest number of sodas, Z is equal to 12, so X is 12 minus 2, or 10. And Y is 25 minus 2 times 12, which is 1. So there'd be 10 small, 1 medium, and 12 large sodas. Of course, you could pick any other value of 12 in there, any other value on that interval from 2 to 12, and get various sizes of sodas. Okay?
Now, how did you know Z had to be greater than or equal to 12?
Go back.
I missed that.
Okay, you know
It made
Z.
sense when you said it, but then
Okay,
continue.
let me say it again and explain a little bit more. Z has to be non-negative, because you can't sell negative sodas, right? Okay. Well, if Z can't be negative, that means the value of X can't take any values where Z minus 2, because that's the value of X. Z minus 2 has to be positive, or 0. So that's why you knew it had to be greater than 2. No, that's okay. Your puzzle is probably somebody else's puzzle. Okay, This tells you that z has to be the one variable that you use to get the solution, the one you can change, okay? Because it says 0 z's equals 0. Well, of course it does. But, you know, z could be anything else too, okay? So you're gonna write your solution in terms of z. So x, using the top equation, x minus z equals -2. Let me see if I can swap this over. Okay, now, this row tells you that 0 z's equals 0, and z could be anything. But it has to be a positive value. Okay? And that means basically that z has to be equal to or greater than 0. Okay, then this equation, to put it back in equation form, this says 1x plus no y, so I'm just going to leave them out, minus 1z has to be equal to -2. So if I solve that for x, x has to be equal to -2 plus z, or z minus 2. Either way you want to write it. That makes sense? Okay. Now, can you sell a negative number of these sodas? No, x also has to be greater than or equal to 0. So that means that z minus 2 has to be greater than or equal to 0. And that means that z then has to be equal to or greater than 2. Okay? Then I go back and do the same thing to find the y's. This tells me no x's plus 1y plus 2 z's equals 25. That tells me then that 1y equals -2z plus 25, or 25 minus 2z. Either way you want to write it's okay. It doesn't matter about which order the terms are in. And then since I know that y also has to be equal to or greater than 0 because it can't be negative, then I know that this expression or this expression, either one, have to be equal to or greater than 0. So that means I'll add 2z to the other side, divide both sides by 2. This is 1. No. What did I do? 25 equals 2z. So that's 12.5. And that's just z. And the sign right now is pointing this way. So if I want to flip it over, it's still got to point the same direction. And z has to be equal to or less than 12.5.
Would you divide by -2 and get a
You could.
12.5?
Yeah, you can, but you still have to flip the sign around. And you could actually verify that by trying to let z be 13. You'll see that you can't get a valid solution, because if z is 13, you're saying that 1x minus 13 is equal to negative 2. 1x, no, wait. That should have worked. Maybe it's not the x's that caused the problem. X equals, add 13 to both sides. That would be negative 11. No, it would be negative. It would be 11, it would be positive 11. But then y would be, oh, I wrote it down wrong. Going back to this, if z is 13, y plus 2 times 13 equals 25. Y plus 26 equals 25. Y equals negative 1, and you can't have that happen. You can't sell negative 1 sodas. Does that make more sense now? So any number between 2 and 12 will give you different values for the ordered triple that solves the problem. We have several different possible solutions. But anything outside of the maximum and the minimum solutions, you're not going to be able to use, because it will give you a negative for one of your other variables. Now, if it was an abstract problem, you know, just solve this system, and it asks you the same thing, well, sure, you can have negative solutions. It doesn't matter. But not on this one. Okay. I think we're about done. Okay, here's our problem. I'm going to let you solve it, but I want you to help walk me through how to set up the equations. We'll do that part together. Can't solve it till you've got the equations. So this says, company makes 2 models of bikes, Model 201 and Model 301. So I guess we'll let X be the Model 201 and Y be the Model 301. Oh wait, I think we did this one, didn't we?
We didn't.
We did it. We already did it. Do you have your answer still?
Yes.
Go ahead and type them in. And I think that's the end of this section.
There's no solution to that.
Yeah, that's right. And that's what you type in, no solution.
You write it in, no
Yeah.
solution.
Just no solution. And since this is the end of it, when you're finished, you can just exit out of the presentation. Now I can go into the next section, or I can let y'all work on your homework for a few minutes and see how you're doing.
I have a question on it.
Okay.
Now, can I put this in matrix form and put it in if I have a solution? If not, I worked this out differently.
Use the matrix. That's all right, knows what you put in.
Oh, you bastard, I'm stuck at 2 hours last night. Sorry, pardon me, I didn't mean to say that out loud, but I was stuck
No, I
at 2 hours
understand.
last night.
I understand.
Where was this last semester, the matrix formula, when we were in summer classes?
All right.
Yeah, like that would have been so easy breezy beautiful.
Well, matrices used to be really hard to do because we had to do them by hand.
Yeah, forget that, when you first started showing us the matrix, I'm like, I'm not doing it this way. But, yeah, once you
Yeah.
put it in the calculator, I'm doing it this way.
Well, the rest of the sections, actually, without me even telling you how to do them, you could probably go in and do them now, because you can add matrices together, you can multiply matrices together to get to solve other kinds of problems. The only thing you have to be careful of is that you get the matrix set up for each side.
Well, and like I did the rest of these, the echelon method.
You can do it, but it's very tedious.
It was very tedious, it was not fun. And that's why with that one, I was like, oh. So.
But the only thing,
awesome.
that's what I was saying, in here, which the matrix, but don't do it the way they say, when you come
Yeah.
up with a problem, then you can't get help.
No, you click the, question help button, and there's something on there, ask my instructor. And it goes to me.
I've seen that on the.
Yeah, it does, it goes to me. When it was in D2L, it didn't go anywhere. That was one of the problems with having it in D2L, that's the reason I'm glad we got out of D2L. Because when they tried to cram it in D2L, it kind of messed up lots of things.